because this is a historic day for us all. Let us pray to Lord Rama for his divine blessings upon all humanity. Jai Shri Ram. Good evening to all. Myself, Dr. S. Vasundhara, Assistant Professor of Mathematics, G. Narayanamma Institute of Technology and Science, Hyderabad. So my talk was related to Introduction to Vedic Mathematics, Indian Knowledge System, Perspective to Vedic Mathematics. The Indian knowledge system is one of the oldest and most sophisticated in the world, encompassing a wide array of discipline, including mathematics, philosophy, astronomy, and more. It has deep roots in ancient Indian scriptures and texts. Mathematics holds immense significance in the Indian knowledge system as it forms the basis of various other disciplines such as astronomy, architecture, philosophical concepts, and it is deeply intertwined with spirituality and practical applications. The ancient roots of Vedic mathematics, which is deeply rooted into Vedas, and it is also in ancient Indian scriptures. It compasses unique methods and approaches for arithmetic and algebraic operations. In this ancient roots, the innovative technologies completely depends on 16 sutras and 13 subsutras in Vedic mathematics, and it is introduced unconventional at systems approaches to solving mathematical problems with ease and efficiency. So the practice of Vedic mathematics, which is interwoven with Indian culture, spirituality, and everyday life, making it a holistic and profound system of knowledge. Since this Vedic mathematics is a unique and ancient system of mathematics, discommuted in ancient Indian texts known as Vedas. It compasses a set of principles and practices that facilitates the swift and accurate solving of mathematical problems. To explore the basic principles of mathematics, the form of the foundations are from Vedic mathematics. So it offers unique and swift techniques for different types of algebraic operations like addition, subtractions, enabling the practitioners to carry out these operations mentally and with great agility. Using these techniques, which are derived from the fundamental principles outlined in the ancient texts. The father of Vedic mathematics was Swamiji Bharata Krishna Tirthaji. So we can explore some of the unconventional methods for addition and subtractions. So these sutras, we already explained here, there are 16 sutras and 13 subsutras are there. These are refers to a set of aphorisms that serves as guiding principle for mathematical operations, and the subsutras are representing the subsidiary principles, enhancing the applicability and efficiency of Vedic mathematics. So the techniques for this Vedic mathematics, which are involving the complementing of numbers to create a more manageable calculations that often utilizes for complex additions, and this presents an ingenious methods for multiplication, division, allowing the individuals to perform these operations mentally with remarkable speed. These techniques are deeply entrenched in Vedic principles and they are designed to simplify the complex calculations. This mathematics, Vedic mathematics, finds the diverse applications in the field such as computer science, cryptography, educational curriculum development, and mental mathematical powers. It has the principles and techniques continuing to inspire innovative approaches to problem solving and mathematical operations. Let us explore here the sutras and how we are applying for different types of algebraic operations. There are 16 sutras, namely Ekadikena Purvena. This is the first sutra. Simply we can say that by one more than one before. Second one is Nishkalam Navatascharam Dashat. All from 9 and the last from 10. Vyadvatiya Vyadvatiriyagyam. Here we can do this multiplications vertically and crosswise. Parvatya Yojayet. Transpose and applying. Shunyam Samya Samuchaye. If the Samuchaya is the same, it is 0. Prapnuyatye Shunyam Prapniyat. If one is in ratio, the other is 0. Sankalana Vyavakalanabhyam. By addition and by subtraction. Purna Purnabhyam. By the completion or non-completion. Chalana Kalanabhyam. Differential calculus. Yavadunam. By the deficiency. Vyapti Samaptiha. Specific and general. Soshadhyena Charamena. The reminders by the last digit. Sopanatvyam Manyat. The ultimate and twice the penultimate. Eka Nyunena Purvan. By one less than the one before. Gunita Samuchayaha. The product of the sum. Gunaka Samuchayaha. All the multipliers. So what is the first sutra here? Ekadikena Purvena. By one more than one before. This is the sutra we can apply for squaring of numbers ending in 5, like 75 whole square, 25 whole square, 55 whole square. This type of sutra, Ekadikena Purvena, we can very particularly calculate the product of two numbers, squaring the numbers which are ending with 5. For example, if you want to check here the general method of our squaring the numbers, which the ending of the number is 5, 65 into 65, how we are multiplying here? 65, down we are writing the 65. First in the units place, we are multiplying. 5 5s are 25. 5, the 2 can carry to the 10th place. 5 6 are 30, plus 2 is added, 32. Now coming to the 10th place, the second digit can be multiplied. This is general multiplication of the numbers. Whereas applying this mathematics, we can easily do the calculation. What is the formula here? Ekadikena Purvena. By one more than one before. Here 65 into 65, multiply that first digit places like 5 into 5, generally it should be 25. Next, coming to the 10th place, Ekadikena Purvena. That means multiplying the previous digit 6. Ekadikena. We are more than 1. 6 more than 1 means 7. So 7 6 are 42. Now we are writing that 42 in the next place. So 5 5 is 25. Ekadikena Purvena. Means what happened here? 6, 10th position 6, we are adding 1, that is 7 6 are 42. Now let me tell any of you 95 square. Can anybody? 95 square. Can anybody help me out writing by using this Vedic principle Ekadikena Purvena? Units place we are writing 5 5 is 25 as it is we are writing. Coming to the 10th position Ekadikena Purvena 9 we are adding 1. So 10. 10 into 9 90. So the value should be 9025. For example, if you are writing 45 square, same 45 into 45, Units place, we are writing 5 5 is 25. Ekadikena purvena. 4 is in the 10th place. We are adding 1. So 5 4 is 20. So now that value should be 20 25. Can anybody 65 75 square? Can anybody? 75 square. Can anybody help me out writing the value? By using this units place, we are writing 5 5 is 25. Ekadikena purvena. So 6. What is the next place? 7. 7 6 is 42. The same way you are writing for 75 square, because squaring of numbers ending in 5, we are applying the first principle. Ekadikena purvena. We are applying this principle to the number which is containing units place is 5, ending the number is 5, squaring them like 25 square, 35 square, 15 square, something like that. So, ekadikena purvena means units place, you are writing 5 5 is 25 as it is. Next digit, adding 1, multiplying the previous digit 6 by 1 more than. Suppose 6 is there, why 1 more than means 7. 7 6 are 45. Suppose there it is 55 into 55. 5 5 is 25. 5 more than 1. 6 5 is 30. That means that is the value 30 25. Now, coming to this value, the sutra Anurupyena. This is the sutra formula known as the proportionality or similarly. This sutra is highly useful to find the product of two numbers when both of them are nearer to the common basis, like nearer to the common basis like 50, 60, 70, etc. Multiples of powers of 10. There you can apply the sutra Anurupyena. So 46 into 43, for example. In that general method, we are writing units place, we are multiplying, then comes to the 10th place. This is the simple multiplication. Whereas coming to this Vedic mathematics, 46 into 43 come to 46. This is nearer to 50. Because in that formula, what we have here, nearer to the common basis, for 46, nearer to the common basis is 50. Similarly, for 43 is also nearer to the common basis is 50. For 50, 46, how much less? Less means here minus 4. For 43, coming to compare with the next base 50, how much it is less? 7 less. So it should be minus 7. Now you are writing here correspondingly units place. See, 46 into 43. Correspondingly that units place we are writing 6 46. 4 7s are 28. But while writing the 28 here, 46 7. What is the summation of 46 and 7 here? Correspondingly, it should be 39. But in the 10th place, it should be less than 50. Therefore, while taking the product here, 1978. This is called as the Anurupyena formula. In that case, what we are doing? To find the product of two numbers when both of them are nearer to the common basis like 50, 60, etc. In that case, if it is less, we are writing that how much less to the nearer to the common base. If it is more, suppose it is 52, then it is more to 2 for the next base 50. So accordingly, you are writing the vertical multiplication and the diagonal summation. If it is more than that 50 base, you are writing as it is the product. If it is less, how much less we are subtracting from the next base. Next one is Nikilam Navatas Charamam Dashat. Nikilam Navatas Charamam Dashat. This formula can be very effectively applied in multiplication of numbers which are nearer to the basis, like same thing like what we discussed in the previous 10, 100, 1000, etc. The sutra Nikilam Navata Charamam Dashat means Navatas Charamam Dashat. Navatas, all from 9, and Charamam Dashat, last from 10. Charamam, end, Dashat, and the all from 9 and the last from 10. Suppose you are taking a simple example here. Navamam, see here, Navatas Charamam Dashat, Nikhilam Navatas Charamam Dashat, all from 9 and the last from 10. So 97 into 94 or 92 into 95, something like that. Navatas Charamam Dashat. Now coming to the simple example here, 97 into 94. This is a 2-digit number. To take the product here, little bit we have to calculate. General method, how we are writing, the same way in modern methods, how we are writing here, units place multiplication, then coming to the 10th position, accordingly we are placing the positions and we are multiplying. But the same multiplication we can easily do with this Vedic mathematics. 97, what is the nearest base? 100, but how much it is less? 3 less. And 94, what is the nearest base? 100, but how much less it is? 6. So we are writing 97, 94. For 97, how much it is less? 3. For 94, how much it is less? 6. Now take the vertical multiplication of this 3 and 6. We are writing 18. Now coming to 97, because this is less, no? For 6 from 100, this is less. That is why 97 minus 6 you are writing. So what is 97 minus 6? 91. Now the total value should be 9118, because here this 3 and 6 are lesser values. Suppose if this is 102, then it should be plus 2. If it is 105, then it should be plus 5. But in this case, 97 into 94 product, for 97 lesser 3, that means it should be minus 3. For 94, it is lesser 6. So it should be minus 6. Now, vertical multiplication, 3 6 are 18. We are writing them as it is. You can take the diagonal multiplication, diagonal summation. 94 minus 3, 91 only. 97 minus 6, 91. That means while taking the diagonal summation, either from initial first to 97 to 6, also the sum is 91, because this is minus 6. 94 to minus 3, also the sum is 91. That means totally we have the value 9118. Similarly, we can take an example of if it is lesser, for example, we can take 102 and 97. Suppose then 102 means this is more than 100, nearer to the base is 100, and it is more than 100, so it is 2. Coming to 97, this is also the nearer base is 100, but how much lesser value? Minus 3. Now take the vertical product. So 3 2s are 6, and 102 minus 3 means how much it should be? 99. So what happened here? Correspondingly, you can have the corresponding multiplication. Similarly, if you want to take 91 and 96, suppose 91 means this is lesser the basis. What is the 91 nearer base? 100. But how much less it is? Minus 9. For 96 also, the nearer base is 100. How much less it is? 4. So minus 4. Now take the vertical multiplication. 36. And 91 minus 9 means how much it is? 87. So the total value for 91 into 96, if you want to multiply, the value should be 8736. This is called as the Nikhilam Navatas Charamam Dashat. Here, what we are doing? multiplication of the numbers which are nearer to the base, like 10, how much it is nearer to 10, or it is nearer to 100, or it is nearer to 1000. Accordingly, whether it is more than 100, how much the difference, or it is less than 100, how much the difference, we are writing separately, taking the vertical multiplication. Then correspondingly, the diagonal summation we are writing from first position to the opposite diagonal, or from second position to the upper diagonal summation we are writing. So this is called as the Nikilam, Navata, Charamam, Dashat, all from 9 and the last from 10. That means this is the formula useful for the numbers which are multiplied by 9, like 95 into 97 or 98 into, that is Navatas Charamam Dashat. Now coming to that is the first case. What is the case here? When both the numbers are lower than the base, because 97 is, what is the nearest base? 100, but this is lesser. 94 is also nearest base is 100, it is also lesser. That means the first case is here, both the numbers are lower than the base. Then how we are taking? 97 how much lesser for the base 100? 3. 94 how much lesser for the base 100? 6. So we are taking vertical multiplication of this 3 and 6, 18, and the diagonal summation 97, 6 means this is lesser, so 97 minus 6 means 91. This is the first case, assuming that both the numbers are lower than the base. Now coming to the second one, in the same Nikilam, Navatas, Charamam, Dashat, when both the numbers are higher than the base, previously 97 into 94, 95 into 93, something like that, Navatas, Charamam, Dashat, whereas coming to the second case here, both the numbers are higher than the base, like 102 into 107, 103 into 105, something like that. So in that case, what we are doing, both the numbers are higher than the base. Suppose you are taking the number 103 and 105. Coming to this 103, this is the nearest base is 100 and this is higher than the base. How much higher? 3 is the higher value. 105 is also the nearer base is 100, but how much higher it is? 5 higher. So we are writing for 103, higher is 3, nearer base is 100. For 105, nearest base is 100 and higher 5. Now we are taking the vertical multiplication, 3 5s are 15. You can take the diagonal summation, 103 plus 5, because this is higher, so we are writing as it is the summation. Suppose this is minus 5, then 103 minus 5. But this 3 and 5, both the numbers are higher than the base. Whether lower base or higher base, simply are taking the diagonal summation. While taking the diagonal summation, then it is minus 5, 103 minus 5. If it is plus 5, 103 plus 5. So for 103, what is the higher value for the nearer base? 3. 105, what is the higher value for the nearer base? 5. Now take the vertical multiplication. 3 5s are 15. You can take the diagonal summation, either 105 plus 3 or 103 plus 5, that is 108. So 10,815. Suppose we are taking another simple example of both the numbers are higher than the base. Navatas Charamam Dashat 109, and we are taking here 112. For 109, what is that nearer base? 100, and how much higher? 9. For 112, the same nearer base is 100, higher value is 12. So 12 nines are 108, and this is already in second decimal places, you are writing 0. So 109 plus 12 means 121. Now you are taking here 121 and 108. Now coming to the third case, first one is both the numbers are lesser than the base. Second case is both the numbers are higher than the base, but not every time it can possible. One number is higher than the base and one number is lower than the base. In that case, how we are writing? The third case is here when one number is more and the other is less. Maybe that is the first number or second number. The same way here, suppose you are taking a simple example of 103 into 98. You are taking that example 103 into 98. 103, what is the nearest base? 100, and this is higher than the base. How much higher? 3. So you are writing 3 in the next position. For 98 also, the higher number is, no, what is the nearer base? 100, but this is lesser than the nearer base. How much lesser? 2 lesser. So you are writing that minus 2. Now, take the corresponding value here. Now, taking this 103 minus 2, if you want to simplify here, 101 coming to 3 2s are 6. Simplifying here, 103 into 98. Since 3 2s are 6 here, but it is lesser, therefore, from this 102, you are subtracting the corresponding value. That means 10,094. After writing how much higher than for the nearer base here plus, for 98 how much lesser than the nearer base minus. So this is plus 3 and this is minus 2. Now we are taking the corresponding simplification of Navatat Charamam Dashat. You can take the corresponding. So for 98, how much lesser it is? Minus 2. Now taking the vertical simplification here, 3 2s is 6. Nearer that base is 10. So you are writing 10 and 103 minus 2. So 101. One value, so it should be 10,094. Now coming to another sutra, Urdhva Tiryagbyam. Urdhva Tiryagbyam. So previously we did that product related to, first sutra is related to taking the squares whose one of the digit is ended with 5, 25 square, 35 square, 45 square, etc. like that. Second one is while taking the multiplication of the numbers where the two numbers are lesser than the base, two numbers are higher than the base, any one of the number is lesser than the base and one number is higher than the base. In this case, Urdhva Tiryagbyam, the two-digit multiplication by Urdhva Tiryagbyam. For example, you are taking 46 into 43. The simple product is here. Both are having the same base. Suppose you are saying that x, both are x. And this is the corresponding A and B. Now simply you are writing x times x plus A plus B plus AB. Say here, this is my C and A is C. So suppose first to take the vertical multiplication of the units place. Vertical multiplication of the units place, how much it is? 6 3s are 18. Then take the diagonal multiplication sum. 4 3s are 12 plus 4 6s are 24. Now it should be 36. Then come to the second place product. 4 4s are 16. Then what happened here? After taking the simplification, Urdhva Tiryagbyam. Now, units place is 6 3s are 18. You are writing that 18. Then, taking this corresponding diagonal multiplication and the simplification of the rest of the sum. So, what happened here? 46 into 43. 6 3s are 18. We are writing that 18 in the first position. Then what is the summation here? B into F. You are taking the summation. So 49 and the corresponding simplification. So we will get here 1978. That is called as the Urdhva Tiryak Vyam if it is the case of two-digit multiplication. Now coming to the three-digit multiplication, because here both are same ending with the text, no, xa like xb, so x times x plus a plus b plus ab, you are writing the formula here, x times x plus a plus b plus ab. That is a Urdhva Tiryavyam we are applying for the two-digit multiplication. The same way we can go for that formula of Urdhva Tiryavyam for three-digit multiplication. In the three-digit multiplication, you are writing here, first step is units place vertical multiplication. Say here 103 into 105. In that units place, what we have 3 and 5, write them, the product is 15. Then you can take it as step 2, coming to that place in that 10th position, 0 product, what happened here, 0 into 5 plus 0 into 3, so it should be 0 only. Now what is the step 2 here? Taking the corresponding 10th place diagonal summation, diagonal product summation. 0 into 5 plus 0 into 3, nothing but that is 0 only. So you are writing 0. Now coming to the third step, what we are writing here? This is unit place, 10th place, 100 place. Take the product. 1 into 5 plus 3 into 1. What happened here? 1 into 5 plus 3 into 1 plus 0 into 0. So 1 into 5 plus 1 into 3, 3 plus 0. So it should be 8. Now this 8 we are writing in the hundreds place. So what happened here? 8. Then what is finally? A into E plus B into D. That means again it should be 0 only. So you are writing 0. Then what happened final? A into D. So 1 into D. That means what happened here? 103 into 105. First we are taking the vertical multiplication of the units place. You are writing aside. That is the value 15. Then coming to the 10th position, because we are writing units place multiplication, 10th place multiplication, hundreds place, etc. Coming to the unit place multiplication, 3 5s are 15. We wrote it in aside. Now coming to 10th position, what is the product of this sum diagonal? 0 into 5, 0 plus 3 into 0, 0. So that is 0. Then you can go to the third position, all multiplication, hundreds place. 1 into 5 plus 3 into 1. 1 into 5 plus 3 into 1, 5 plus 3, 8, and 0 into 0. So it should be 8. We are writing in the hundreds position. Then coming to the last step, diagonally for this one, 1 into 0 plus 0 into 1, that is 0. Then finally, 1 into 1. So first we are writing C into, suppose you are saying this is A, B, C, D, E, F. First to take the units place multiplication, that is C into F. Then 10th place multiplication, B into F plus C into E. What is the summation? Then cross multiplication of all the respective positions. Units place, 10th place and hundreds place, diagonally taking the summation. Then finally 100 place position, last 1 into 1. So here it should be 3 into 5, 15. Then this is 0. Then we are writing the total 1 into 5 plus 1 into 3, 8. Then finally it should be 1 into 1. So you are writing 10,815. This is the three-digit multiplication which is known as the Urdhva Tiryavyam. Previously, that is also Urdhva Tiryavyam, two-digit multiplication. In that, what we wrote, simply taking that units place multiplication, then directly we are writing what is the diagonal values. So we have written 4 3s are 12 plus 6 4s are 24. 12 plus 24, that is 36, and 4 4s are 16. 16 plus 3 19. So it should be 1978. The same way, coming to 3-digit multiplication, instead of 2, we are writing first vertical multiplication, then 10th place multiplication sum, then 100th place multiplication, totally we are writing. The same way we are going for the remaining principles also. As of now, I am learning the things of Vedic mathematics for all the 16 sutras and sub-sutras. Till now, I had some knowledge about how we are taking the corresponding multiplication of 2-digit and 3-digit with using these three principles. What is the first one? Writing the square of two numbers, which is ending with the number 5. And second principle is the numbers which are taking the 2-digit multiplication with the lesser than the number, and both are lesser than the base, both are higher than the base, and one is lower the base and one is higher the base. And in this Urdhva we are taking the product of two number multiplication and also the similarly three number multiplication. We have here like 16 sutras are there. Ekadikena purvena nishkalam navatas charmam dashat vyadvitiryagyam paravartya yojayet shunyam samya samuchaye prapnyuchaye shunyam prapnyat sankalana vyavakalanabhyam purana purnabhyam. So these are all the things we need to learn slowly by taking the corresponding multiplication and the simplification of the results. While entering into the type of the products, we can easily find out the key sutras of simplification of the numbers. So this unique approach of this simplifying the multiplication of numbers, particularly useful for large and complex numerical calculation, this gives a very good advantage, no doubt about this Vedic mathematics we have to learn. So what are all the key principles here? Just now we explained here, it is containing 16 sutras and 13 sub-sutras. In the 16 sutras, we slowly learn what is the meaning of every sutra and what is the corresponding sub-sutra, because we have 16 sutras on only 13 sub-sutras are there, because using the 13 sub-sutras, one or two are mapping to the corresponding sutra only. That is where there exists only 13 sub-sutras, which are efficient strategies for solving the mathematical problems and performing the complex calculations also. So, while coming to this cryptographic algorithms for this Vedic mathematics, it has utilized in that encryption algorithms that enhances the data security and privacy, especially in the field of the computer science, educational curriculum development, and mental mathematical powers also we can apply. And the corollaries are here which accompany the sutras that provides the additional information for the principles and guidelines for applying the technique of Vedic mathematics to various mathematical operations. And it is no doubt universal applicability of this Vedic mathematics, because it is offering the versatile techniques that can be applied to various branches of mathematics, that real life problem solving scenarios. Like just now I explained about how we are applying this cryptography to encryption of the algorithms that enhances the data security and privacy also. And this Vedic mathematics techniques are showcases in high stake mental health competitions and demonstrating their utility and the efficiency also. We can apply this Vedic mathematics. So the coming to the benefits and the advantages of learning this Vedic mathematics, using this we can enhance the speed and accuracy, because while taking the multiplication, not like our traditional way of simplifying in the units place and tens place, simply you have to remember the sutras. while remembering that every sutra, in that meaning only we have ekadikena purvam, navatas dharmam dashat, nikilam. So such a type of sutra, if you want to recollect that name of the sutra, then immediately you can take that number, particular number, whether it is applicable for ekadikena purvena or which is higher than the base, or the two numbers are higher than the base or lower than the base, or one is higher and one is lower, like that you can easily get a glance about the particular number. Then immediately we can apply what is the particular rule for taking the multiplication of the number, etc. So it makes that mathematical calculations very less time and more accuracy. With that Vedic mathematics, we can improve our mental clarity also. The practice of Vedic mathematics helps improve the mental clarity and agility, contributing to overall cognitive developments and problem solving abilities and applicability in competitive exams. The methodical approaches in Vedic mathematics proves the beneficially for students preparing for competitive exams, providing a competitive edge in solving mathematical problems, efficiency. So that the adaptable nature of Vedic mathematics provides the practical and inventive approaches to addressing the complex problems across various industries, and it promotes that the cognitive creativity among the students also. So, application of Vedic mathematics in our everyday life, how we are applying for quick mental calculations, allows that every individual to perform the quick mental calculations for everyday tasks such as budgeting, shopping, and time management. Problem solving skills also improves using this Vedic mathematics can our real life situations, offering the practical solutions for various mathematical challenges encounters in our day-to-day life. Cultivating the logical thinking. By utilizing this Vedic mathematic principles, individual can cultivate logical thinking and analytical skills, enhancing their overall approaches of problem solving, decision making, etc. They can do that. So, what are all the techniques for mental calculations in Vedic mathematics? Just now we have explained about the three sutras, no, digit sum, and in this digit sum, Vedic mathematics introduced the concept of digit sums, enabling the rapid addition and calculation of the final sum through concise steps based on the digit values. Base methodology. In that base methodology, while taking the product of two numbers or more than two numbers, simply it is referred to the what is the nearest base of that particular number. Suppose if you are writing 43, it is nearest base is 50. How much it is lesser? 7. Suppose you are writing the product of two numbers 55 and 65. In that 55, the base is 50. How much more? 5. 65, you are writing the base is 70. Not it is every time you are writing 10, 20, 30, 40. You can write the base of power of 10, 20, 30, 40, 60, 50, 70, etc. Accordingly, using the base methodology in Vedic mathematics equips the individuals with efficient techniques for multiplication, division, and the other mathematical operations that is completely based on the foundational principles. And squaring and cubing, first one is ekadikena purvanta. That means the squaring and cubing the technique in Vedic mathematics offers the ingenious approaches to swiftly calculate squares and cubes of numbers through structured and organized methods. In that example of, so how we are applying these examples and practice problems in Vedic mathematics: speedy multiplication, instant subtraction, efficient division. So Vedic mathematics techniques for rapid multiplication of multi-digit numbers, for quick subtraction of the numbers, utilizing this Vedic mathematic principle for efficient and straightforward division also we can apply. So overall, we can take the division of a number by nth power of 5. You can take an example of here. For example, what is the rule for division of a number by nth power of 5? Multiplying the given number by 1 as number of 5. For example, 5 power 3. That means n is equal to 3. Multiplying the given number with 2 because power is 3. That is 2 into 2 into 2, division of a number by nth power. So what is the first one? Multiplying the given number by 2 as number of 5 power n means if it is 5 power 5, you are multiplying 2 into 2 into 2 into 2 like 5 times. Lastly, second, because this is the division of a number, divide the result of steps by that many number of 10. For example, if you want to divide that 29 divided by 5, that means generally it should be 5.8. So how we are writing 29 5 power 1 only, no? Because one time you are taking 29 into 2, that is 58. Now 58 divided by 10, because lastly divide the result of step by that many number of times. How many times we are powering, that many times we want to divide that number. So 29 divided by 5, 5 power 1. So we are multiplying only one time with 2. That means 29 twos are 58. So one time we are multiplying the same, that resultant number we are dividing with 10 directly. That means 58 divided by 10. That should be 5.5. So 29 divided by 5 is like 5.8. Similarly, if you want to take 216 divided by 5 power 3, that means we have to divide it 125. Now, what is the step 1 rule? Multiplying the given number by 1 as the number of 5 power n. So, 5 cube means we need to multiply 3 times of 2. That is 216 into 2 into 2 into 2. That means what happened here? That should be 1728. Now, since it is multiplying 3 times, 10 power 3, that means 1728 divided by 1000, that is 1.728. So instead of 216 divided by 125, you are writing that value 216 into this is 8. So 1728 divided by how many times we are taking? 3 times. So 10 into 10 into 10, that is 1000. That means 1.728. Like the way we are taking the division also. So what is the further resources for learning this Vedic mathematics, which offers a rich tapestry of mathematical wisdom that complements the traditional mathematical approaches, presenting the innovative techniques for streamlined mental calculations and problem solving. To delve deeper into this ancient system of mathematics, individual can explore various books, courses and online resources also dedicated to the Vedic mathematics, since it is representing the timeless and innovative system of numerical computations, offering the interactive methodology and profound the insights into the world of numbers. So it's enduring the significance lies its ability to merge ancient wisdom with the modern applications, enriching the global mathematical landscape. The influence of Vedic mathematics extends far beyond the academic realms, permeating the numerous facts of contemporary society and contributing to the evolution of mathematical thoughts. So, with this, I'm ending the session. Thank you for your attention. Let me know, is there any doubt? Since I am also learning this Vedic mathematics, and I learned till 3 sutras. So I explained what I learned, and simply I'm sharing my knowledge with you. Thank you.